All right, we're gonna get started here, and it's my pleasure now to introduce Ms. Deborah Grubbe, fellow member of NAC and the vice chair of the safety committee, as well as a former chair of the NAC Safety Committee. Deb has over 30 years of engineering management, operations, turnarounds, and safety leadership of the for the process industries. She's a recognized industry safety leader with extensive experience working with DuPont, BP, CII, and AICHE. She worked with NASA after the space shuttle disaster, which I didn't know, and received a Distinguished Public Service Medal from NASA for that work. Congratulations. She's collaborated with the Department of Defense and NIST and has contributed to the National Safety Council and the International Safety Council. Deb is a distinguished alumnus of Purdue University, which awarded her an honorary PhD in 2010. Congratulations again. That's fantastic. Please join me in welcoming Ms. Deborah Grubbe.
Thank you very much, Tony, and good morning. It's a pleasure to be here with you today. And I stand before you as someone who has spent a whole bunch of time in industry. And the subject I'm going to be speaking with you about is education, safety in education. So with all respect and due respect to all of the official academics in the audience, I got this go-do by Hashtag, so I'm going to do the best I can with it, Mark. But we're going to talk about engineering education and how safety fits in. And I have to start at the very beginning because one of the things, the reason why I'm standing here before you today is that my father was a high voltage lineman for Commonwealth Edison in Chicago. I was born in Illinois, came to Purdue, and so you guys won out over all the Illinois schools on me, but that's where I learned about safety. Because I realized at the age of 6 in a dinner conversation that if my dad didn't work safely, he might not come home. And that's a pretty when you're an only child, okay, that's a pretty impactful kind of thing to have happen. So my passion for safety is quite strong. And so it's no surprise that when I go to Purdue and I get my degree in chemical engineering and I go to interview for a job and it's 1977, okay, so you can figure out how old I am. And then you go and you take a look at the fact that there weren't a lot of women in engineering. Everybody was trying to hire a woman. I got 17 job offers that year. And the question was, who are you going to go to work for? What resonated with me with the DuPont company was what? The safety culture. Because I grew up with it. And so my safety message for everyone today is what my father taught me. He said, honey, he said, electricity is extremely unforgiving. You can't see it. You can't smell it. You certainly can't taste it. If you ever get near it, it's got you. And so, you know, just think about all that. He said, it's there. And you never know it until you're too close and you have a problem. So that's the piece of it. What I learned in my early career at DuPont was that engineers need better knowledge about safety before they leave the university. One, to help them be more competitive on the job site when they get there. And not everybody, and this is now we're talking late 80s, early 90s, there weren't a lot of safety courses back then. And if you got it, you sort of got it through the job experience through a cooperative education or a summer job. And that was good. But the point was, the university can help this because it's not just the safety piece, and that's one of the pieces I'm going to part. So I decided to become part of the solution because it fit my personal passion. So the question is, why is this industrial person talking about how to put safety in education? It's because we worked here to try to do some of that, and this is going to be a bit of the story. So we're going to talk about why safety in the engineering curricula, and this is not just the process industries that has this problem. So I'm coming to you from a chemical engineering perspective, but the MEs, the double E's, and all the other disciplines are there. Purdue has done some great work on it, both in the classroom and as you heard earlier from what's going on. I'm also going to be giving you an update on the New Jersey Institute of Technology safety status, on what they're doing, and an update on that from last year's symposia. We were to have a speaker in our panel for that, but their graduation is today, and so the professor cannot come. And so we are going to share some of his information with you. And then a forward challenge. So this is how I get students' attention. One engineer with one mistake can kill more people than any other professional. So that's why we should teach safety in engineering. And it's not just this notion of calculation errors. There's enough safety factors in our design, if you look at handbooks and all that stuff, there's enough of that in there that you have to exercise some care, but we're not talking about, there's some good old Kentucky windage in a lot of our designs. The real issue that I have found, and I think the experience backs up when you take a look at the incidents, and I've been on the inside of some pretty major incidents, it has to do with silence. And the engineers know something's not right, and they're afraid to say something. So this becomes, at some level, personal ethics, an understanding of what is that process in where they may be working. So we'll talk a little bit about that. So safety, in my view, cannot really be accomplished without strong ethics. You need leadership, but you need ethics. If you have a lot of people that don't have a good set of personal ethics, you will have problems. And this is not just the process industries. If you think about 1978, the Ford Pinto had the gas tank problem, okay? That's where sort of Lee Iacocca got his first piece of it. Then in 2014, the GM ignition switch, where the engineers knew there was a problem, didn't want to spend the extra couple dollars, literally, to change the switch, and at least a couple hundred people died. The VW emissions scandal, where the managers were cooking the books on their computer program so that their cars could pass the emissions tests. The managers knew about it and kept a secret, but it took the US EPA to find it. The 737 with Boeing, the notion of a product launch that went awry because we're trying to save money on software development and hired it out to people who really didn't understand, and then we didn't integrate it or think about it, the management process on the backside, because when you go out and you farm out planes, rather than build it all yourself, you farm out planes, if you don't do the integration work on the backside with the systems and the hardware, you're going to have a problem, as well as the space shuttle incidents. So these are, sometimes you have people who are in the workplace that get hurt. Many times it's your product and the people using your product that get hurt. And so How do you differentiate from that? And my point is, you don't. So the responsibility on an engineer to understand safety and the responsibility on the faculty to teach safety is extremely important to everybody. So what did we do at Purdue? This really started with a lecture in chemical engineering to chemical engineering juniors around ethics. And they liked it because I got the whole class to shut up and listen. Because I told the one guy was, screwing around in the back, and I said, I'll never hire you. I want to make sure I get your name. I'm never going to hire you. And he said, why? I said, because if you're not serious about listening to a conversation on ethics, then I don't want to work with you. Because that means that I have to trust my life. If I'm working with you, I have to trust my life to your judgment sometimes. And I don't want that. Because that was really bad judgment you just exhibited there. And that the whole class got silent. Anyway, chemical engineering then requested a safety curriculum. And so the sophomores, and this was Linda Davis, who was working as a professor in the laboratories that were being developed at the time. And she said, I want to give sophomores a laboratory course, a driving safety course, and maybe something else. And we said, sports safety. Something to get them introduced to the subject that's relevant to them at their age and what they're studying. The juniors would learn about occupational safety because many of them either may have just had a sophomore summer experience or are going to be going to work for a summer experience. And then the seniors have a process safety experience for chemical engineers. That's important. It's also important for all the other engineers out there too. But, or did I just lost? Now it's back? I'm back, thank you. All of a sudden my voice sounded different. So we did the senior course. So we did 3 courses tried to do it in a couple of days. And did all of those, and then the seniors at the end of that course, that senior course, came up and said, can we have a full course on process safety? And to their credit, the chemical engineering faculty said, tell us some more. So they did, and the course got started. So this was a student-requested course because they realized, okay, and I've had a chemical engineering classmate of mine died at work on a plant in New York. It wasn't a DuPont facility, but got hit by a train on the job. So the train was, I don't know what the circumstances were, but she's no longer with us. So what were the motivations and the drivers behind this? Top tier companies have rigorous safety culture. We heard about that earlier today. This notion of process safety provides business benefits that include corporate responsibility, business flexibility, risk reduction, all that good stuff. And I would tell you that having built chemical plants and having worked and managed manufacturing operations of high hazardous piece, yes, chemical engineers have to know a lot about process safety, but so do civil engineers. Because if you don't understand process safety and you're working in the environment, you may inadvertently create an issue for the manufacturing facility. So there's a real important effort to make sure you understand what is process safety as it's defined by OSHA now, and as it's being redefined and has been redefined by the industry. The U.S., the Code of Federal Regulations, that's the PSM regulation, is 14 elements. And the current new type of guidance, which is not yet part of OSHA, but where all leading companies are going, is 20 elements. So anyway, There are many examples where this lack of safety culture has adversely affected companies, their employees, and the community. And I can tell you, as I was talking to Alicia and Tom earlier, I was house hunting in London. I was retiring from DuPont and going to work for BP. And I was house hunting in London, and I was on a plane on the way back, and that was the day that Texas City had its explosion. And here I was coming in as the VP of Group Safety for BP, and I realized when I heard that, I said, my job just changed. And I can talk to you about cultural differences because there was night and day difference culturally between DuPont and BP. And I knew that when I took the job. But then I really saw it in action. So and BP today is a much smaller company because of not only Texas City, but because of what happened in the Gulf of Mexico. Had to sell off a lot of assets, stock has never recovered, billions of dollars of value lost. And so if you don't think this stuff is important to teach engineers, I'd like to have a conversation with you and hear why you think that. Other motivation. There's a growing regulatory interest in the US around how do we prevent this stuff. OSHA's been running a national emphasis program. That's stopped now. It was under previous administrations. But they're still sensitive to it because there's not that many refineries. We continue to shut down old US refineries. And sooner or later, we're going to have to bite the bullet and build one. And that's a real interest. That'll be an interesting time. There's been lots of retrofits, and that's keeping us going at this point. And process safety education will be a good requirement for accreditation that's coming. So if you look at it, the critical requirement for PSM is one is what is it and being aware of it. The individuals and companies, and this is just verbatim from a presentation that was made, and so my apologies for not making it more succinct, but I didn't want to lose anything that was there. This notion of not simply a conscious behavior. So this notion of how companies behave, how management teams behave. I mean, I had, going back to the Texas City incident, I hadn't even started work yet, hadn't moved to London yet, had just gotten the lease set up on my flat in London, and I got a call from the president of BP America who said, can you tell me what are some options we have? And I said, I only know two options when you have an incident such as this. You have to go and you say, from a business standpoint, you have to go, if you want to go open kimono, basically, tell everybody what you did wrong, go through an internal study, bare your soul to the world, make it a learning opportunity for everybody else. He said, or what? I said, the other extreme, which is the stiff arm, I'll see you in court, I'm not telling you anything, which doesn't fit to me how you've postured yourself, with your marketing plan. And the comment was, okay, that's really good thinking. And so this comes out, and they go with the Baker panel report, and that was all predicated as part of the open kimono. So that's why all that came to pass. That was not what the lawyers in London wanted to do. So the summary was there was a 3-credit elective course. It was offered for the first time in the spring of 2011. Professor Mike Harris was the faculty member who was responsible for teaching the course. And I was very fortunate to have Ron Cutchall and Steve Swanson. Steve's no longer with us, so thank you, Steve and Ron, to work with to help augment the faculty. And Linda Davis became the champion and the administrator. We had some prerequisites, but the objective was to develop knowledge of PSM in the process industries for the chemical engineers. And I continue to talk about the importance of understanding process safety management if you do any work in the process industries. So no matter what degree you have in engineering, you have to at least understand this at some level. So the format is lectures, videos, and reports on safety incidents, and luckily, we have many, many, many incidents we could talk about. And the final exam was a little different, and the final exam was a team-based exam because this course focused on leadership. It didn't get into the details of the calculation because, that's the issue is one of leadership. If I'm a student, can I smell when something's sour in my culture? That's what we wanted to teach the students because then you know you have to do something different. And so we actually did it based on the Buncefield incident in the United Kingdom, and we changed it to make it look like O'Hare Field, and they were the student team of 6 that had to go through this as the final exam had certain time frames and new information was coming into them, so they had to make assumptions and they had to adjust this. And the professor who decided to teach the course later changed it, and that's okay. Everybody's comfortable, that's his prerogative, and I'm good with that. But I think we lost a little bit of the leadership piece of what would you do if this happened to you. And so I'm sensitive to time, and there's a whole bunch of stuff, but this gives you what is process safety management. You have to understand your regulatory landscape. You have to understand people, technology, the facilities, your management team and your leadership team, what they're willing to do and what they're not willing to do. What are their motivations? Because I can tell you that people that told me, there were people in the Gulf of Mexico organization in BP that told me when I went to visit them, and they said, oh, we don't have any problems. So when the safety manager in a large oil and gas operation says, oh, we don't have any problems, that's not how I would think about it. Okay, so the fact that something happened there, okay, lesson. And he said, go spend your time with refining. They need it. Upstream's great. I thought, okay, I don't think so, but all right. So other course topics. How do you analyze hazards? And different ways of thinking about hazards. And different mathematical things that you can do with respect to it. What's the hierarchy around, and what's the risk, and what is the negative or the positive of doing qualitative hazard assessments versus quantitative hazard assessments. This notion of risk management, and this is where other things come in, and you'll see this. You'll see, where are you in the capital project? And in the overall project skills, where are you and how is safety impacting each of those projects, each of those phases of the project? Are you doing your process safety analysis at the very beginning? Those kinds of things. All of those are really critical. This notion of risk management, again, incident investigation, safety culture, all of that is part of PSM. So there's some overlap between occupational safety and process safety management. And the notion of AICHE also has some types of modules that if you're interested, you can use. The professor can just lift them and go and use them. But I think the key message is a couple of visiting type of professors who had industrial experience said, we need more. The students responded. The alumni got involved and helped to create it. So I think that might be a potential way to deal with it. And so if you look at today, the process safety course is now required. So this course is no longer an option or optional. It's now required in the curriculum. And it's being taught by Ray Menser, who's retired ExxonMobil. And also another professor, Osman Bassaran, manages the Purdue Process Safety and Insurance Center, which is a collection of industries that start to do research on topics that are of interest to them with respect to process safety. And I just finished a gig for the IChemE Safety Center in the UK, and they're a member of Bassaran's program. So there's a lot of interconnectivity with the other parts of the world on this. And if you look at outside of chemical engineering, I realized that I said I better check to see what kind of courses in safety are in other disciplines here at Purdue, because my lens had been focused more on chemical engineering. And if you look, there's a number of courses that are very specific, with the exception of lab safety requirements. So students are getting some fundamental lab safety requirements at Purdue, which is good. And that's probably being handled in the freshman or sophomore year. And I couldn't find much on civil engineering other than the traffic safety course, and I'm sure there's much more. I just couldn't find it. It was buried in courses, probably, and that's good. That's no problem with that. So NGIT update real quick. This started last year with the safety workshop, and the champion of it is the Dean of Engineering, Dr. Kamm, and he has taken it and has basically put some resources behind it. And Samuel Lieber is the professor who's doing this work. They've created an undergraduate minor in safety engineering that's 5 courses, a total of 15 credits. Has industrial collaboration throughout the effort, and this was all started last year because of one of these workshops. They also have a global course and a credential if you only want to take 1 or 2 courses. So if you're an undergrad and you can't take all 5, you can have 1 or 2 and pick up some credentials, which I think is positive. It helps reinforce this notion of they're working also and created a 15-credit graduate certificate on and with occupational safety and health. And they're focusing on ABET and internal quality systems at this point in time. All of the courses are across all disciplines. They're open to the entire university and all their engineering disciplines. In Newark, it's the Newark College of Engineering, if you're more familiar with that term. There's a customized plan of study for quality and reliability. The engineering management course subjects include legal, quality, economics, team construction, human factors, and leadership. So it becomes more of a management kind of course, but it's focused on engineering. And ethics is a part of that. And they also have these 1-credit electives that students can take if they have interest. And so there's a lot of flexibility. And these are the disciplines: construction, biomedical, devices. These are other groups where they have access to these types of courses. And they're developing in biomedical and devices, since they're in that area, they have companies are going to be helping them with all that. And I think that's a positive. And let's see. So the forward challenge is no matter what your perspective, and no matter what the discipline, I think we owe our students a good foundation. Thank you for your time.
Thank you.
Thank you.
Can I give you one of these?
Sure.
Yeah, there you go.
Thank you very
much.
much. Thank you very much.